Hello students, in this video let us discuss the method practical harmonic analysis to obtain Fourier series. So what is this method? You have seen in all previous video we have discussed how to find a Fourier series when we know the function in the interval. Suppose there may be a situation we don't know the function, instead we have the values of x and y, means independent and dependent values. In such a cases, how to obtain the Fourier series? So that is practical harmonic analysis. Practical harmonic analysis, it is a process of finding constant term and few cosine and sine terms numerically. In general, we have the Fourier series given by f of x is equal to a0 divided by 2 plus summation n equal to 1 to infinity an cos n pi x by l plus summation n equal to 1 to infinity bn sin n pi x by l over the interval 0 to 2l. Suppose if we set pi x by l is theta, we get here cos n theta sin n theta, and we expand this by giving the values of n by 1, 2, 3 so on. We get the Fourier series after expansion like this. F of x is equal to a0 divided by 2 plus a1 cos theta plus b1 sin theta plus next n equal to 2 a2 cos 2 theta plus b2 sin 2 theta. Likewise, it will continue. Here, this a0 by 2 is called constant term. Then we have the next a1 b1 part, that is called first harmonics. Next a2 b2, that is called second harmonics. Likewise, third harmonic, fourth harmonics we can obtain. Now let's see how to obtain the Fourier coefficients. In general, the mean value of the continuous function is given by 1 over b minus a integral a to b f of x dx. Now we are discussing the Fourier series over the interval 0 to 2l. Therefore, a is 0, b is 2l. So we get 2l minus 0 2l integral 0 to 2l f of x dx. This is average value of continuous function. Now to make it is a0 formula, we should multiply. So by multiplying 2, this 2 gets cancelled. If you multiply 2 here, this 2 gets cancelled, then it will become 1 by l 0 to 2l f of x dx. Therefore, you can write this as this is 2 times mean value of f of x. Mean value of f of x. The same meaning gives us in a statistical procedure, because we don't know the function, instead we have the x and y value. So we should use the way of using the procedure should be summation. So that is 2 times summation f of x divided by number of equidistant points. Therefore, a0 is given by the formula 2 by n summation y. So it is integration only the function with respect to x. Here the y nothing but f of x. a1 is 2 by n summation y cos theta. Average value we are taking here. So divide by number of equidistant point taken out. a2 is 2 by n summation y cos 2 theta. Similarly, we have the formula for b1, b2, b3 so on. So it is b1 is 2 by n summation y sin theta. b2 is 2 by n summation y sin 2 theta. Just we take it is in general n theta. Then by giving n values 1, 2, 3, you can define a1, a2, a3. Similarly, b1, b2, b3. A all belongs to cosine terms. B terms all belongs to the sine terms. a0 is containing only y. So it is a constant term. Similarly, we have the Fourier series over the period 2 pi. So that is, you know that f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx plus summation n equal to 1 to infinity b n sin nx. If you expand the series by giving n values, we get f of x is a naught by 2 plus a1 cos x plus b1 sin x plus a2 cos x cos 2x plus b2 sin 2x. Likewise, we can continue. Here also we call a naught by 2 is a constant term, and this group is a first harmonic, and a2 cos 2x plus b2 sin 2x is the second harmonics. So we define a naught to a1, a2, b1, b2. So same way the average value we are calculating here. A naught is 2 times average of y. A1 is 2 times average of y cos x. A2 2 times average of y cos 2x. B1 average 2 times average of y sin x. B2 2 times average of y sin 2x, where n is number of equidistant points. Now let's discuss the working procedure to obtaining the Fourier series numerically, means by practical harmonic analysis. First, we have to write down the period of the function from the given range of the values of x. Secondly, if the period is 2 pi, so we are working on two types of periods. One is 0 to 2l, other one is 0 to 2 pi. If the period is 2 pi, so depending on the harmonics required, whether you require first harmonics or second harmonics, we have to prepare the table. So along with the summation of y cos x, y cos 2x, y sin x, y sin 2x. So if you want first harmonic, Fourier series up to first harmonic, you have to find only a naught, a1, b1. So means you have to prepare y cos x, y sin x summations using the table. If you require continuing a2, b2, then we have to find y cos 2x, y sin 2x summations from the table. And we can use the formula to find the harmonics. Next, third step, if the period is not 2 pi, then we have to equate the period is 2l, whatever, so it can be 0 to 6, then 2l is equal to 6. Okay, and obtain the values, value of l, here l is 3, like this. Then the summation of y cos theta, because if the period is not 2 pi, we have to prepare the table for theta, this is pi x by l. Then we have to prepare accordingly y cos theta, y cos 2 theta, y sin theta, y sin 2 theta, depending upon how many harmonics you required. So let's get started with the problems to understand the method harmonic analysis. So let's start with the problem. We have here express y as Fourier series for first harmonic, means we need to find only a naught, a1, b1 for the given data. So given that x 0 to 360, means the interval is given 0 to 2 pi. It's a 2 pi format. When it is pi format, so we no need to consider theta is what. Okay, that is not required. Only we have to prepare the table for y cos x, y sin x. Like this we have to prepare the table. Before that, very important, students, you have to check. It should be always for the first value of the interval and for the last value of the interval, the y value must be same, like this, 7.9. When you are calculating summation values, we are not using either first one or last one. We are neglecting either first one or last one when you are using calculating summation. Okay. So for what all Fourier coefficients we require to find? A naught, a1 and b1. So let's prepare the table now. Then we find a naught, a1, b1. Let's prepare the table now, and we are noting the value column wise, the given x and y. So here x values all taken, and we are excluding 360. For summation values, we should exclude either first one or last one. Y value So for this corresponding x value, all y values are noted. Now we have to calculate y cos x, y sin x. You can use the calculator, you can fix y cos x equation in your calculator, and careful what type of values we have, radian values or degree values. So normally we keep in this case degree values, calculator mode should be in a degree values. So let's start finding. For the y is 7.9, x is 0, what is y cos x? So it is 7.9 because cos 0 is 1 into 7.9. Similarly, so what 7.2 into cos 60 gives us, it is 3.6. Next we get 3.6 into cos 120, that is minus 1.8. Next 0.5 into cos 180, this is minus 0.5. Next 0.9 into cos 240, this is minus 0.45. Next we have at the end y is 6.8 into cos 300, it is 3.4. Next we find y sin x in the similar way. 7.9 into sin 0, 0. Next 7.2 into sin 60, it is a 6.2352. So 3.6 into sin 120, it is 3.1176. Next 0.5 into sin 180, 0.5 into sin 180, it is 0. Similarly 0.9 into sin 240, it is minus 0.7794. Next we have 6.8 into 300 sin 300, it is minus 5.8888. Now let's take the total. What is the total summation? So summation y, on taking addition of all the values, we have here 26.9. Next we want y cos x summation, it is 12.15. Next we require summation y sin x, it is 2.6846. So like this we have to prepare the table depending on how many harmonics we require. Since we are finding the Fourier series up to first harmonic, we have prepared only y cos x, y sin x. If you want more than this, you have to prepare y cos 2x, y sin 2x, y cos 3x, y sin 3x in this way. Now let's find Fourier coefficients to obtain the Fourier series. We have the formula. A0 is 2 by n summation y. So where n is what in our problem, how many entries you are taken for calculation? See here 1, 2, 3, 4, 5, 6. So in the problem, in the question you are observing it is a 7, but you are excluding 1, and also n is number of equidistant points. So therefore n is 6 here. Okay, therefore it is 2 by 6, summation y is what? 26.9. Then it will be 8.9667. Next, similarly, you can take 2 by 6 of summation y cos x, that is 12.15. On calculation of this, it gives us 4.05. Next, same way, 2 by 6 of summation of y sin x, it is 2.6846. So gives us the result 0.8949. After this, we also calculate what is A0 divided by 2. It is called constant part in the Fourier series. We have A0 is 8.9667 divided by 2. The answer is 4.48335. Now we write the Fourier series up to first harmonic. This Fourier series f of x is A0 divided by 2 plus A1 cos x plus B1 sin x. This is the Fourier series up to first harmonic. Okay, then we substitute what we have calculated, a naught by 2, it is 4.48335 plus a1 is 4.05 cos x, b1 is 0.8949 into sin x. So this is the solution required. So let us discuss another problem over arbitrary interval. Okay, we have the problem here. The following values of x and y are given. Find the Fourier series of y up to second harmonics. Okay, values are given. X is 0 to 5, y is 4, 8, 15, 7, 6, 2 corresponding to the x value. Very important, we have to observe firstly what type of interval. Arbitrary, 2L interval. Interval 2L is given. Then what is 2L? Is it 5? No. So why it is not 5? We have the 4 in the starting. We don't have 4 at the end. That is mainly we need to observe. It means we have the another value. It is not mentioned because starting and ending is always same. Observing the common difference of x value, ourselves you can define the next value in the table. Next value of x must be 6 and the first and last should be same. So you can write, so x is 6, y is 4. Then the interval given is not 0 to 5, it is a 0 to 6. It is 0 to 2L format. Then what is L value? L is 3. Because 2L is 6, L will be 3. That is very important. Next, we have to prepare the table by taking theta. Theta is pi x by L. So we get it is pi x by 3 for L value. And since we required Fourier series up to what harmonics? Second harmonics. What are all we have to calculate? Those are A0, A1, B1, C, A2, B2. Up to second harmonic means these are all Fourier coefficient we need to find. First, let's prepare the table accordingly how many harmonics required. So given that x and y columns, so that we have note down. So x value is what given, let us take that, and y values correspondingly, let us take that. Here since the interval format is arbitrary, we have to consider theta. So instead of writing just cos x, cos 2x, sin x, sin 2x, we have to mention it is a theta because it is an arbitrary interval. It makes our problem simple if you are considering theta separate column. Now we have theta is because L is 3, no, pi x by L, pi x by 3 taken. Now we substitute for x, x is what, 0, then theta will be 0. We are converting all radian values to degrees. That makes our problem simple. Now taking this is 0 we get. Next if you substitute x is 1, it will be pi by 3. Pi by 3 nothing but 60 degree. Okay, you can take like this. Once you are getting these two values, so then what you can do, next difference is what, 0 to 60 degree, it is so just 60 degree. Then we add 60 to every value. Like this ourselves you can define. 120 degree, 180 degree, next 240 degree, next 300 degree. Like this you can take. Then as like previous problem, let us calculate y cos theta column. It is substituting y and theta values in the equation y cos theta. We get here 4. This is 4. Next minus 7.5. Next minus 7. Next we have minus 3. Next we have 1. Same way, y cos 2 theta, substituting theta is 0 and y is 4, we get it is 4. Next minus 4, minus 7.5, 7, minus 3, minus 1. Now let us substitute y is 4, theta is 0 to this equation. It gives us 0. Next we have to substitute y is 8. Theta is 60 in this equation. It gives us 6.928. Similarly, other values 12.99. Substituting theta is 180, y is 7, it is 0. Next substituting theta is 240, y is 6, we get minus 5.196. Next substituting 300 as theta and y is 2, we get minus 1.732. Next this is also, by substituting this is 0 and this is 6.928 minus 12.99, 0, 5.196 minus 1.732. Next we take total of this required. So total of y is calculating 4 plus 8 plus 15 plus 7 plus 6 plus 2 gives us 42. Similarly, let us calculate, add this all value gives us minus 8.5. Next, y cos 2 theta summation is minus 4.5. Summation of y sin theta is 12.99. Next, summation of y sin 2 theta is a minus 2.598. So after finding all the summation, we find that what is A0, what is A1, A2, B1, B2 using the formula. So first we take what is our n value, number of entries we have taken for calculation, it is n is equal to 6. Therefore, what is A0? It is 2 by 6, means 1 by 3, summation of n y, it is 42, then on simplification it gives us 14. So I'll take A0 divided by 2, constant part is here only, it is 7. Next, similarly, it gives 1 by 3 of minus 8.5, it is minus 2.833. Next, 1 by 3 of minus 4.5, it is minus 1.5. Next, A2, A1, A2 all done. Now we'll calculate B1. It is 1 by 3 of 12.99. Gives us 4.33. Next, 2 by n. 2 by 6 is a 1 by 3 of y sin 2 theta summation minus 2.598. It is minus 0.866. Okay. So we have calculated all Fourier coefficient numerically. Now we write the Fourier series for the calculated value. So Fourier series for this, what you have to write in general, f of x is a0 divided by 2 plus a1 first harmonic cos theta we have to write because it's an arbitrary interval. Theta is a pi x by L plus b1 sin theta. You should not write x. Or you can write instead of theta, you can write pi x by 3. When it is 2a2 cos 2 theta, in the place of 2 theta, you can write 2 pi x by 3. In that way also you can enter. Plus b2 sin 2 theta. Now we substitute for every Fourier coefficients. Where a0 divided by 2 calculated as 7, a1 is minus 2.833 cos theta. I have to write because cos theta ourselves to avoid the confusion of it. Theta is what? Pi x by 3. B1 is what? B1 is minus 4.33. 4 plus 4.33 sin pi x by 3. Next, second harmonic plus a2 is minus 1.5 cos 2 theta 2 pi x by 3. Next, b2 is minus 0.866 sin 2 theta sin 2 pi x by 3. So like this we have to write finally the result.